Hi, my name is Steve Bowler, and in this video I'm going to be configuring the VTY lines on the router using just a standard ACL. So we're just going to be filtering subnets via using standard ACLs implemented on the VTY lines, our virtual terminal lines on the router. What I have here is PuTTY Connection Manager. As requested from one of the subscribers to the channel, they asked why I don't use PuTTY and the PuTTY Connection Manager. So I really didn't have a reason why I didn't use it. So I do a lot of going back and forth between screens. So what I did was I set up PuTTY Connection Manager, and it really helps save a lot of time in between screens and all that. I don't have to go in between the windows and all that anymore. So anyway, really cool function. You can Google that, just Google GNS3 and PuTTY, and you'll have some stuff that comes up right there at the beginning on how to implement that. But in this video, we're going to be configuring We're going to be configuring an access control list to control, our VTY lines on our router. So what I'm going to do here, as you can see, I've got this simple network here. Router 0, I have the 10 and the 20 loopback interfaces. 10 for loopback 0, 20 for loopback 1. Then I have the connection between them, which is on the 172.16 network, and then I have loopback 0 on router 1, which is on the 1 network. Okay, so what I'm going to do here is go into the routers now and just configure them real fast. Right now I'm on router 0. Configure the host name, and right away I'm just going to set the timeout. So my session doesn't time out, which can mess up the CPU utilization on your on GNS3. And I'm going to configure the fast Ethernet interface 172.16 1.1 with a /30 subnet mask. And then loopback 0 is 192.168 10.1/24, and then interface loopback 1 is IP address of 192.168 20.1. And then what I'm going to do, I'll just run router RIP version 2, no auto summary. So it becomes a classless routing protocol, and then what we'll do, we'll just advertise our networks. So 172.16.0.0 and network 192.168 10.0 and 20.0. So show IP protocols shows us we're running RIP, and now we have here, you can see here the routing protocols RIP. We have our interfaces that are running RIP and our networks that we're routing for. The whole class B 172.16, and we're running 192.168 10 and the 20. Okay, so now what we need to do is go here to router 1. Would you like to enter the initial configuration? No. You know what we're doing. I think so. I hope so. Anyway, okay, so we're going to go, this is router 1, so we're going to configure for hostname router 1. Line console 0 is the console port that we're on now. We're going to set the exact timeout to nothing so that it doesn't time out on us. Now we're going to go and configure fast Ethernet. IP address 172.16. We're going to go to, what was it, 1.2/30. We're going to go loopback 0, do IP address 192.168 1.0. I'm sorry, 1.1/24. Now we're going to go under router RIP. We're going to do run version 2, so we can do classless, which is no auto summary for version 2. Then under here we're going to run for network 172.16.0.0 to incorporate our fast Ethernet to router 0. Then we're going to do network 192.168 1.0. Now if I do a show IP protocol, you can see here the networks I'm routing for, the interfaces on the router that are part of the RIP routing protocol, and let's see here. If I do a show IP route now, you can see that I haven't learned anything yet via RIP. Let's do something real fast. I think I know why that is. Yeah, it's because my fast Ethernet interface is not admined up, so I'm going to go under my fast Ethernet 0.0 and do a no shut. And let me check router 0. So I have a hunch that I did the same thing here. I didn't admin up the fast Ethernet. Yep, same thing. So go under fast Ethernet port, do no shut, and now if I do I'll give it a second here, if I show IP route, I don't see any RIP routes yet, so if I do a debug IP RIP events, just trying to see if I can see the RIP process. Okay, so here we go. So what you see here is my RIP network was converging here. You're sending the flash update on the multicast address of .9.224.0.0.9, which is RIP version 2. Basically sending out the routes and to our neighbor. Now if I look at our routing table, you can see here that I learned the route via RIP from router 1. So if I try to ping it, 192.168 1.1, I'm good to go. So if I go back to router